Alright guys, this is Mr. Johnson coming back at you with another fantastic, wonderful, delightful episode of homework. You had a request to make a video for how we're supposed to graph in Excel our spectrophotometry data. So I'm sorry it took me so long to get around to this, but here's the gist. Okay, so in your data table, we calculated together the molar concentration of our solutions based on the dilutions, and it turns out this is actually 80%, and 60%, 40%, 30, 20, 10, and 0% of the original solution. Okay, and that's because of how we diluted it. And then we plugged it into our machine. We read out a data point, which was the measurement right here, percent transmittance. Okay, and of course I could tell Excel to read this as a percentage, and it would do that. But why do we need to worry about that? Okay. Basically, from math class, if you remember, 0.0677 is 6.77%. That's the same thing. Okay, so 1 is 100%. So we go from 6% light getting through our solution for the darkest one, highest molar concentration, down to 100% of the light going through when we just plug in 0% molar concentration, or water, 0 molar concentration of water. And so that'd be nice. I mean, we could go ahead and I can show you how to graph this really quick. If I highlight my data, go to Insert, and then click on the little graph with the dots. I want a scatter plot. Okay, and you can see that's a wonderful wonderful graph. However, definitely not linear. You see a nice curve in that graph, an exponential decay. And so we need something different. Okay. Now, in order to deal with this, of course, nowadays it's no problem. You could take that, plug it into your computer, and get an equation and solve for it. But it's a lot easier to deal with in whatever equation you're dealing with, as if it's a linear equation. Y equals mx plus b is way easier to deal with than y equals negative log of ax plus I don't even know whatever. Okay, so what we need to do is transform these values in the percent transmittance into absorbance values. Okay, and in order to do that, we type in our equation. We have an equation that will translate percent transmittance in decimal form to absorbance. Okay, but you could do this on a calculator. You could go in and tell it to take the negative log of this and write down your number and type in each one in a box. But you're in Excel already, so why don't we just use Excel? Okay, now if you see when you type log, it gives you a couple of options. We want to choose log 10, returns the base 10 logarithm of a number. Okay, and so we do log 10. Okay, as a function in Excel, you need to open your parentheses, and then it says that inside you need this number. Okay, so we can either click or press the left arrow to go over, but you want to take this cell to the right of the absorbance cell, hit enter, and that's telling Excel, okay, I want the negative log base 10 of this number to the left. Okay, now I can go ahead and retype that in here, equals negative log 10 of what's to the left, boom, and I could redo that for all of these, but Excel has a lovely feature two ways. Number one, you can grab this corner and pull it down, or number two, you can actually just double click on that corner and it will autofill everything that has a data table or a point forward to the left of it. Okay, so now I've got molar concentration and I've got absorbance. This is where it gets a little tricky though, because you don't want to select all of this data and graph all of that on the same graph. We only want to select this column and the absorbance column. So if you actually hold down control, left mouse, and drag it down, you can select both columns. Then once again, if you remember, I go over to Insert, I click on my scatter plot, and voila. Okay. Now this is not a complete graph because it's missing a couple things. Number one being your axes. Okay, you always need axes, and so there are a couple ways to add it. Number one is to come up to quick layouts, and you can select whichever one of these. Of course, we don't want all the data points on there. We don't need to put a line in there yet. We want more than just the horizontal axis, so you can select. Usually the first one works, and then you just right click and delete what you don't want, the absorbance where it has those values over there. Or you can click on this plus sign and tell it that you want to put titles on your axes. Okay, and then of course you can go back in here and relabel those, which would be molar concentration, and on this axis, absorbance. Okay, now usually we title these. We just do the dependent variable versus the independent variable. So I'll say absorbance versus molar concentration. Okay. Now, of course, you should have units on there, and I'll give extra credit to anybody who can figure out how to put a micro symbol in there. I think it's in here, insert symbol somewhere. I don't know. Anyways, so that's the idea. You've got your lovely graph. Now, how do we add a line of best fit to it? Well, to do that, you're going to right-click on the data points. Any one of them will work, and you'll see it pulls up this menu, and you've got Add Trend Lines. Click on Add Trend Line. Gives you lots of different options. Now, for our other graph, we could have actually chosen a logarithmic. It might have worked all right. Way easier to deal with this, though. Okay, so you can see that's a straight line. It goes pretty much right through everything. You can set your intercept to 0. We do actually want that to be equal to 0, but in this case, it's all right. Just leave it the way it is. We do definitely, though, want to display our equation. Okay. Now, there are a couple ways that you can figure out what your absorbance is for your gate array. Okay, I'm going to go back to my original sheet here. So we measured in class the transmittance of our power rate, gate array, whatever it is. Okay, and that's good and fine, but how do we use that to figure out the concentration? Well, remember the whole goal of making all these solutions was so that we could, in the end, take our gate array, our power rate transmittance, and plot it on this graph and figure out, well, okay, if it's 0.6, then we come down to the x-axis and find, well, it has to be somewhere around 4 micromolar. Okay, so we need this as an absorbance, first of all. So remember your equation for absorbance equals negative log 10 for cell of this number, okay, 0.318668. Okay, now you can go and kind of wing it and look like, looks like it's right there, and maybe that comes down to, I don't know, 2.3, 2.2, 2.5. Or, better way, we can actually use that equation we just figured out right here to calculate. So this equation says that y equals 0.13, y equals 0.132x plus 0.0341. And there's actually a way that you can go through and calculate it out. I mean, there's a function in Excel that will actually pull up the full equation for this line and a whole bunch of different statistics about it. We're not worried about that at this level. We just want to get a basic trend line in there. Okay, so now if I wanted to figure that out, then I would solve for x, right? So I'd do 0.31868 is going to be my y value. I'm going to subtract the 0.0341 is my x value, or my x-intercept, y-intercept, and then I divide by 0.132. Really all I'm doing is solving this for x, okay? And of course, if you remember, for Excel to make a calculation, you have to hit enter, and action, that should be, let me make sure I solved it right. Nope, of course, always remember, your parentheses. Come on, PEMDAS. Okay, there you go. And there would be my precise absorbance, or my precise concentration calculated from our data there. Okay, so 2.1558 micromolar. And that's pretty darn close. Okay, so give me an email if you can't figure it out. Hopefully that gets you on the right track, though. Make sure you're using your own data. Repeat that. Make sure you're using your own data. And good luck. See you tomorrow.